Here we are at our Chapter 5, Target 4, Problem 8a. We're asked to factor using the sum and difference of perfect cubes. Now, in just looking at our problem, we do notice that we have this 27x cubed that is a perfect cube. Now, the number 27 is a perfect cube. Likewise, this x cubed is a perfect cube. So this whole combination of the first piece is, in fact, a perfect cube. Likewise, 1 is a perfect cube. It's just 1 times 1 times 1. But again, though, that 1 is a perfect cube. Here we are seeing the sum of these two perfect cubes. And anytime we see the sum of two perfect cubes and you're trying to break it down and factor it, how that actually comes down is we have a plus b times a squared minus ab plus b squared. So this is how we would actually break down our sum of two cubes. This actually goes back to the San Diego Padres notes that we kind of took from class because at least in terms of the signs, that should hopefully help students out. Pretty much what that means is if we are starting off with a positive between these sum of cubes, the first one's going to be the same sign. The next guy would be a different sign. And then the last guy would be always positive. So again, we use San Diego Padres from class just to help us remember the signs for the sum and differences of cubes. They work exactly the same whether it's a positive or negative here. As long as you use the San Diego Padres method, you should be okay with the signs. And we'll see one when we get to 8b. But first, what we have to do is, just like we were doing with difference of squares, we have to identify what is our a and what is our b. So we're asking ourselves first, what, when we cube him, is going to give us this a cubed, that 27x cubed. Well, just starting off with the number, what number cubed gives us the number 27? 3 would accomplish that. Because our sum of these two cubes does have the variable x, we have to have our x variable to identify with what is a. And we're trying to get x cubed. Well, right now we really already have x cubed, because x raised to the third power gets us that x cubed. Hidden and embedded, it does have that exponent here of x to the first. And again, using power to a power property, we would multiply these exponents and get that x cubed, which is what we're looking for. Likewise, we're going to go ahead and ask ourselves what cubed gives us that b cubed, that number 1. Pretty much, hopefully a lot of us can see it, the number cubed giving us 1 just comes out to be 1. Because 1 cubed, or 1 times 1 times 1, gives us what we're looking for, 1 here. In doing that step, what we have done is we have identified, hey, here is our a, here is our b. And pretty much all we have to do now is go ahead and throw them into our nice little factoring form. So we have a, which is 3x, plus our b, 1, times our a being squared. Now what's really important to note is that it is the entire a being squared, so that's 3x being squared, minus our a, 3x, times our b, 1, plus our b being squared, so 1 squared. Now what we would do last is just simplify this up. So the entire first piece is actually fine. It's still just 3x plus 1. For the second piece, we have 3x being squared. We're going to go ahead and distribute that squared to both items. So the 3 is actually getting squared, giving us 9. Likewise, the x is getting squared. Minus 3x times 1 is just 3x. And then lastly, 1 being squared is just positive 1. So this would be our factored broken down form for that sum of those two cubes. Again, that is our Chapter 5, Target 4, Problem 8A from the study guide.